Welcome to this video. I'm Physics and today we are going to be going over wave equation and key definitions. First of all, we're going to be going over key definitions for waves. Amplitude means the maximum displacement from the equilibrium position. Frequency means the number of oscillations passing through a point each second. Wavelength means the length of one whole oscillation. Wave speed means the distance covered by a wave per unit time. And period means the time taken for one whole oscillation to happen. Now we go into the wave speed. Wave speed can be found using the formula V equals F lambda, where V equals wave speed, F equals wave frequency, and lambda equals wavelength. So now we go into the GCSE example exam style question, where it states, calculate the wavelength of the wave using figure 12. So we know that one wavelength looks like that. And we can also see that half a wavelength is from there to there, and another half of the wavelength is from there to there. And on figure 12 you can see that the wavelength is incomplete. It's not one whole wavelength. But we can see we have this distance over here. And from here we can see that it is half a wavelength. So if we find this distance, we can just multiply it by 2 to get the full wavelength. So we need to find out what these individual boxes mean. So we do 15, which is here, divided minus 10, that is 5. And to find each individual box, we need to divide it by how many boxes are in between 10 and 15. And that is 10. So you do 5, which is the difference, divided by 10. And that is 0.5. So we know that each box is worth 0.5. And between 10 and 15, we can see is 12.5. And we just need to keep going from there till over here, where the wave crosses the axis. So we can see is 13 over here, 13.5, 14. So we know that half a wavelength is 14 centimeters. So we just need to multiply by 2 to get 28, and that is the full wavelength. And that is the answer. So now we go into the A-level example exam style question, where it states, calculate a value for the speed of sound using the information shown, where it states, when the frequency of a source is 1.8 kilohertz, the positions of 6 piles and the distance they cover is 0.5 meters as shown in the diagram. So we can see that we will have to use V equals F lambda, which is the wave speed equation. So we're given F, which is 1.8 kilohertz, but we need to find lambda using the diagram above. So we can see that there is 1, 2, 3, 4, 5 gaps. And so lambda over 2 equals this total distance, which is 0.5, divided by how many gaps there are, which is 5. And it is lambda over 2 as there is destructive interference, which we will go over in a future video. And 2 of these gaps equal one whole wavelength. So overall, we can see that lambda, when we rearrange everything and solve it, we can see that lambda will equal 0.2 meters. And so now we just need to find the speed of sound, the wave speed. So all we need to do is do the frequency, which is 1.8, but look, it's kilohertz. So we need to times it by 10 to the power of 3 to get it into hertz. So we get 1.8 times 10 to the power of 3 to get it in hertz, not kilohertz. And we multiply it by 0.2, as that is the wavelength. And when we do that, we get 360. So the speed is 360 meters per second. Don't forget the units, as it's not given, as it is not given. So thank you for watching this video. I hope you have learned something from this video, and it'll be really appreciated if you could share this video and subscribe. Have a fantastic day.